Welcome to SolidCAM Professor in a video series to help you get started with iMachining. In this session, we will discuss the importance of defining a tool and its parameters related to iMachining. This will include topology parameters of the tool such as diameter, cutting length, and number of flutes. Then, we will discuss more specific parameters such as the material database, the tool material and cutting speed, the default machining level, and helical angle. We will continue to use the same milling cam part with iMachining operation that we've just created in our first video. Let's start off by moving back to the tool branch of the iMachining operation dialog. Click Select to bring up the tool table. Let's look at our defined tool in the list. Under the Topology tab, there are three parameters that will have an effect on the cutting conditions in the Technology Wizard. Working from top to bottom, we must set the cutting diameter. We will use our set diameter of 12 millimeters. Next, we'll need to set the cutting length. This is important. For this example, let's use the default value of 24 millimeters for the cutting length. The Technology Wizard uses the cutting length to calculate if multiple steps are needed to achieve the pocket depth. Setting the number of flutes is also important. The correct number of flutes will assure the proper chip size is given to each flute. We will use our tool with the set value of 5 flutes. Let's now switch to the iData tab in the tool table. Here, we can define parameters more specific to iMachining. The material database will be automatically selected using the part default, which we defined when we created our first iMachining operation. Although, it is possible to set a different material database for each tool. Selecting a different material database is used when machining different materials in one CAM project. A fixture is a good example of this. Let's leave the default for now, aluminum with a 100 Brinell hardness number and a hardness Rockwell of 60 on the B scale. Next, let's look at selecting a tool material. This adjusts the cutting speed for a given type of material from which the tool is made. The default is set to carbide at 100%. By selecting a different material using the drop-down menu, a percentage adjustment will be used to calculate the maximum cutting speed. An override checkbox is provided so a percentage adjustment can be set manually as well. For this example, let's use the default option of carbide at 100% for our tool material. Setting the default machining level will position the slider in the Technology Wizard to this level when selecting this tool from the tool table list. Let's set the default level to 5 for this example. Setting the helical angle is important for calculating depths based on axial contact points, or ACPs, which we'll cover in more detail in this session. There are 5 typical end mill angles to choose from, or we may also type in a value. For this example, we will use the default 45-degree helical angle. Clicking Select will confirm the tool definition and exit the tool table. Next, let's switch to the Levels branch of the iMachining operation dialog. In the input field text box, set the pocket depth to a nominal 30 millimeters. We can now switch to the Technology Wizard and see how the values were calculated based on the tool information. We will discuss using the wizard in more detail in our next video session. Looking at the step-down output grid, we can see the wizard calculated 2 steps at a 15 millimeter depth to give us the 30 millimeter total depth. Notice the ACP value is set to 2 and the depth is painted green. Now, let's look at a fully modeled end mill and see where the 2 ACPs come from. Here is the tool with a depth of 15 millimeters. Let's look at a sectional view of the tool's contact area. Not counting the bottom point of the end mill, we can see there are 2 contact points lined up vertically. This is where the 2 ACPs come from. Now, let's move back to the Technology Wizard. The green color for this depth in the output grid indicates that this is a good situation for stability. Let's switch to the Levels branch and change the pocket depth to 5 millimeters. Then, switch back to the Technology Wizard. We can see that the wizard calculated 1 step because the total depth is now less than the cutting length of our tool. The ACP value is now 0.7 and the depth is painted red. Now, let's look at a model showing the 5mm depth to see how the flutes line up vertically. There is no contact point above the bottom of the end mill. The 5mm depth is only 0.7 of the first contact point. Moving back to the Technology Wizard, the red field indicates that this is not a good situation for stability. Let's switch to the Levels branch again and change the pocket depth to 13mm. Then, switch back to the Technology Wizard. The ACP value is now 1.7 and the field is painted yellow. Now, let's look at a model showing the 13mm depth to see how the flutes line up vertically. There is one contact point above the bottom of the end mill and 0.7 of the next. Moving back to the Technology Wizard, the field is painted yellow because we have at least one contact point above the bottom of the tool. Since there is at least one contact point, the situation for stability is okay. Let's switch to the Levels branch one more time and change the pocket depth to 14mm. Then, switch back to the Technology Wizard. The ACP value is now 1.9 and the field is painted green. Let's look at a model showing the 14mm depth to see how the flutes line up vertically. There is one contact point above the bottom of the end mill and 0.9 of the next. Although the depth did not give us a perfect 2 ACPs, there is a 20% tolerance on any ACP over 1. Moving back to the Technology Wizard, 0.9 of the next ACP is within the 20% tolerance, and the depth gets painted green for good stability. Let's switch to the Tool branch and click Select to open the tool table. Keep in mind that changing the diameter, number of flutes, and helical angle will have an effect on the ACP value generated by the wizard. Also, the pocket depth in the Levels branch will have an effect on the ACP value. The wizard calculates depths based on ideal ACPs, as we see in the Technology Wizard branch. When specifying number of steps or step-down value by switching the radio button to user-defined, the ACP value and associated color will still be shown to make you aware of the stability conditions. It is not possible to always be machining with preferred ACPs. But by monitoring the ACP values and the cutting results, over time you may find matching a tool to the current depth to get good ACPs is beneficial. Let's switch to the Levels branch and set the pocket depth back to a nominal 30mm. In the Technology Wizard branch, we'll set the radio button back to automatic so the wizard generates the ideal step-down values and preferred ACPs. This is also where we'll start the next video of the series. And this concludes our second session in the SolidCAM Professor video series to help you get started with iMachining, where we discuss defining a tool and its parameters related to iMachining. Thanks for watching. Please join us for our next session, where we will go over how to use the iMachining Technology Wizard.